So we have this trig equation here, or this identity that we need to prove here. So we start here. The goal is to show that the left hand side is equal to the right hand side here. So here we make these two fractions on the left hand side a single fraction, so we get the common denominator there. Now here the common denominator here is just going to be the product of the two denominators that we have here. So I mean that here we're going to have 1 plus sine theta and 1 minus sine theta, like this here. So if we divide 1 plus sine theta into this here, we remain with 1 minus sine theta. So by 1 here we're going to have 1 minus sine theta, like this here. Then plus, if we divide this into this here, we're going to be left with 1 plus sine theta. We multiply it by 1 here, we're going to have 1 plus sine theta, like this. Then here we have 2 sec theta, the root of 1 plus tan and the root of 1 plus tan squared theta, like that. Now here we know that this here, this part that we have here, this comes from an identity here. We know that 1 plus tan squared theta is equal to sec squared theta, like this here. So if we introduce a square root this side and we introduce a square root this side, these here they will cancel. So we are left with sec theta is equal to the square root of 1 plus tan squared theta, like this here. So I mean that where there's 1 plus tan squared theta, we can just replace with our sec theta here. Okay, so we'll do that. So for now, let's try to simplify what we have here. So the sine function here is negative there, so it will cancel with a positive sine function here. So we are left with 1 plus 1 on top. We're going to have a 2 there. So 2 divided by, we expand the brackets below, 1 by 1, we're going to get 1 by negative sine theta, we get negative sine theta. Then sine theta by 1, we get positive sine theta. Then sine theta by negative sine theta, we get negative sine squared theta, like this. So this is equal to 2 sec theta. Then we said that where there's this term here, we just substitute with this. So 2 sec theta, like this. Okay. So now below here, a negative sine function will cancel out with a positive sine function. Then you're left with 2 divided by 1 minus sine squared theta equal to 2. So sec theta by sec theta, I get 2 sec squared theta. So 2 sec squared theta, like this. Alright, so now we know that from the Pythagorean identity here, sine squared theta plus cos squared theta equal to 1, like this. If we shift this sine function the other side of the equal sign here, we're going to have cos squared theta is equal to 1 minus sine squared theta, like this. So meaning that this side here, where we have 1 minus sine squared theta, we can just substitute with cos squared theta, like this. So here we do the same thing here. We're going to have 2 divided by cos squared theta equal to 2 sec squared theta, like this. Then we know that 1 over cos squared theta gives us sec squared theta, like this. So therefore we can just simplify this side that we have here. So we have 2 open brackets 1 over cos squared theta equal to 2 sec squared theta, like this here. Then we know that 1 over cos gives us a second function there. So we're going to have 2 sec squared theta is equal to 2 sec squared theta, like this. So there we have it. The left hand side is equal to